Did your teacher not explain how modulus functions work? Well, here's the very simple breakdown. We have two lines. And the way I think about it is this is y positive and this is y negative. So why do I label it this? Because all we're going to do to the modulus function is deduce that. The first part is all positive, so we have 2x plus 4 minus 5 to expand out to be 2x plus 3. And then we have y negative, which is equal to 2, and then minus x minus 4 minus 5, which gives us minus 2x minus 8 minus 5 is minus 13. Now, this makes sense. The gradient has to be, well, if we ignore the minus sign, the gradient has to be the same. So this is going down by 2, this is going up by 2. One is negative, one is positive. Y negative clearly cuts the y-axis in the bottom half, so hence minus 13. And we can see that this coordinate up here is positive, so plus 3. We now have our two equations. I should probably label this y negative. And I will always start off a modulus question by writing these two things out. Now we can tackle the question. So how do we find P? Well, we're back to GCSE maths. How do we find a point which two lines cut across? That's simultaneous equations. So let's just do that. We'll call this equation 1, we'll call this equation 2, and we'll do number 1 minus number 2. So y subtract y is 0, 2x minus 2x is 4x, 3 plus 13 is 16, so we're going to get x equals minus 4, and we want to find P. I'm going to assume it's the coordinates. So if x is minus 4, then y is minus 8 plus 3 is minus 5. So P has the coordinates minus 4, minus 5. And as I've said previously, drawing a good diagram is important. My teacher used to harp on about DAGD, draw a good diagram, but then also labeling it as you go along is equally as important. So on to part B, we need to solve this. Well, okay, 3x plus 40. What does that look like? So it's got a gradient of 3, it's going to cut across up here probably, and its gradient is going to be steeper than this. So we're going to assume it looks like that, meaning it's going to have one intersection here and likely one intersection all the way down here with this graph, with this line. So we need to solve 3x plus 40 is equal to this and is equal to this. So let's do that. So part B, we're going to say 3x plus 40 needs to equal 2x plus 3. Therefore, x is equal to minus 37.